Every one of these nodes represents an active WordPress installation. In August 2026, over 100,000 of these sites running BdThemes plugins were simultaneously exposed to a critical supply chain attack. When security researchers audited the event, the results were contradictory. Scanners reported 0 modifications to the official WordPress plugin repository, and every line of source code matched the clean original versions. The attackers had bypassed the official repository entirely. Instead, they targeted the vendor's Upstream cloud infrastructure, compromising a third-party DigitalOcean Spaces bucket that fed data directly into the end-user servers. The developers had designed the plugins to fetch static JSON data streams from this external bucket. Rogue actors obtained write access to that storage space and replaced the legitimate JSON responses with crafted payloads. Because file integrity monitoring tools only scan local files on the web server, they operate completely blind to this vector. If a local file remains unchanged, but is instructed to execute whatever data it pulls from a remote server, the perimeter is breached without triggering a single file alarm. The entry point for this attack relies on an internal component called BigOpti, which shipped natively with the BdThemes plugins. BigOpti was built with a standard administrative function, pulling promotional banners from the vendor's API server and rendering them inside the WordPress admin dashboard using those remote JSON files. Looking at the JSON payload, we isolate the exact vulnerability. The parsing code handles a display ID parameter, but lacks client-side escaping. Without escaping, the application fails to sanitize incoming data. Arbitrary text placed here is executed by the browser as live code. This creates a cross-site scripting flaw that fires silently. Execution requires 0 clicks from an attacker. The payload is activated the moment any logged-in administrator loads a WP-admin page. By hijacking an active authenticated browser session, the attacker inherits the user's privileges. It is a frictionless escalation path that entirely bypasses the login screen and two-factor authentication. Triggered via the API-data-all-records endpoint, the primary w2.js payload launches 3 automated tracks. First, it contacts a command control server for targeting instructions. Second, it generates a rogue administrator account. Third, it extracts a web shell named emmerrun.php via a fake plugin upload. That extracted file is a fully functional PHP web shell, deployed directly into the site's architecture. No manual hacking required. They execute simultaneously, in the fraction of a second it takes the dashboard to load. Once the initial perimeter is bypassed, the attacker automates the system's own administrative features, like user creation and plugin uploads, working entirely within the system to build a comprehensive backdoor from the inside. With the PHP web shell active, the script invokes it to install 2 persistence modules. These are dropped into the must-use plugins directory, a location that executes automatically and is notoriously difficult to disable. The first is a magic login backdoor. By appending a simple URL parameter, the attacker forces the system to grant them unauthenticated administrative access, specifically hijacking the session of the site's longest registered admin. The second module is for operational stealth. This database model shows a standard query retrieving the user list. The stealth module hooks into these queries, mathematically filtering out rogue accounts before data reaches the visual layer. Site owners remain completely blind. In parallel, the attackers deploy an alternate payload, x.js, through a different API endpoint. Instead of randomly generating passwords for these rogue accounts, this payload uses a strict mathematical algorithm. Looking at this formula visualization, the script takes the victim website's hostname and hashes it into a 6-character base36 output. It then directly inserts that hash into a predefined username and password format. By deriving credentials directly from the domain name, the attackers eliminate the need for a centralized database of compromised sites. Knowing only the target website's exact URL allows the attackers to compute the necessary entry credentials entirely on demand. Zooming out to the broader threat landscape map, this isolated incident connects to a wider infrastructure. The exact command and control node used here draws direct lines to recent compromises in 2 other major plugins, ARVE and OptinMonster. These combined attacks point to a systemic campaign aimed at establishing covert administrative persistence across large swaths of the WordPress ecosystem. This requires a shift in how administrators model threats. auditing local code repositories is no longer a complete defense. Security teams must enforce strict content security policies on all third-party API integrations. As long as internal administrative components blindly trust and parse remote data streams without sanitization, a JSON dependency is a direct vector for remote code execution.